Hi everyone, today we're going to be going over factoring. So the first rule of factoring is you have to factor out the greatest common factor. And what the greatest common factor is the largest factor that is common to both of the values in the equation. So for example, let's say we have 6xy plus 9y squared, and the greatest common factor would be 3y. So when we factor that out, we're going to get 3y parentheses 2x plus 3y. And that would be the first step of factoring out the greatest common factor. And the second rule are these three rules right here. And this only works for binomials, but they'll be helpful when you want to factor them out. So first we're going to start with binomials, and what we're going to do is we're going to remember to factor out the greatest common factor, and we can follow these rules up here too if we need help. So x cubed minus 1, we can't factor any greatest common factor out of that, so we're just going to go straight to the rules and see if it matches any of them. So it does match a to the power of 3 minus b to the power of 3, because this equals x to the power of 3 minus 1 to the power of 3. And this is similar to a to the power of 3 minus b to the power of 3. And so here we have a to the power of 3 minus b to the power of 3 equals a minus b, a squared plus ab plus b squared. So we're just going to follow this exact same formula, but plug in x for a and 1 for b. So you get x minus 1, x squared plus x plus 1. So we're just going to basically plug the values in here for this equation right here. So our answer is this. Okay. Now the second question says negative 12a squared plus 27. And we have to remember to factor out the greatest common factor. And the greatest common factor here is 3. But I'm just going to factor out negative 3 because I want to get rid of this negative out in the front right here. So I'm going to factor out negative 3, and we get negative 3 for a squared minus 9. And if we look right here, this follows the a squared minus b squared form because this equals negative 3 2a squared minus 3 squared. And so the 2a acts like the a and 3 acts like the b. So we're just going to plug 2a and 3 into the equation right here. So we get negative 3, 2a plus 3, and 2a minus 3. So that would be our answer. So the next question says x to the power of 3 plus 27, and we can't factor anything out there, so we're just going to start with the rules. And this follows the same rule as a to the power of 3 plus b to the power of 3, because this equals x to the power of 3 plus 3 to the power of 3. And this follows the exact same rule as a to the power of 3 plus b to the power of 3. So we're just going to write this out, but we're going to plug in x for a and 3 for b. So we get x plus 3, x squared minus 3x plus 9. And this would be our answer. Okay, now x to the power of 4 minus 16. And if we can write this out as x squared squared minus 4 squared. And if we look at this, it follows the a squared minus b squared rule, so we're just going to plug that in and write x squared plus 4, x squared minus 4. But we can't stop right here because we can see that this part can also be factored. We're using this a squared minus b squared because this equals x squared plus 4. That remains the same and we can't factor that, but we can go x squared minus 2 squared. And that follows the a squared minus b squared form, so we're going to plug that, only this part, back into the equation, but we get x squared plus 4, and we get x plus 2, x minus 2. So that would be the full factored form. Okay, now we're going to move on to trinomials. So trinomials, you're going to sort of approach it in a sort of reverse FOIL method. So for example, we're going to start with x squared plus x minus 20. So we're going to think of the two factors that multiply to x squared, and that's x times x. Then we're going to think of the two factors that multiply out to negative 20. But first we're going to not think about the negative and we're just going to pretend that it's a positive 20. So let's say I think of 10 times 2 as my first factor. So this is what we're going to do. We're going to write two parentheses. And in the beginning, we're going to write the two factors right here. So x and x. Then we're going to decide whether 10 or 2, where 10 and 2 is going to go. And right now it doesn't matter, so I'm just going to put 10 and 2 here. Then what I'm going to do is I'm going to multiply the two outside numbers. Then I'm going to multiply the two inside numbers. So I'm going to multiply the two outside numbers, and then I get 2x, and then two inside numbers are 10x. And I'm going to see if there's any way that these two numbers will add or subtract to this positive x in the middle. And it turns out that 10 minus 2 is 8, 10 plus 2 is 12, so there's no way it's going to be positive x. So I'm going to change this and think of another two numbers that will multiply to 20. So this time, let's say I think of, instead of this, eliminate that, I'm going to think of 5 times 4. So I'm going to put the 5 here and then the 4 here. And then if I multiply this out, on the outside I get 4x, on the inside I get 5x. Turns out that if I subtract this, I do get positive x. And so these two numbers are going to work. But then we have to remember that we had this negative sign right here that we pretended was positive in the beginning. So now we have to place a negative in front of either negative 5 or 4 so that the two numbers will multiply to negative 20. And so it does matter which side we place it on. So first we're going to look at these two numbers, 5x and 4x. And how will I get to plus x? Well, or positive x. I'm going to put the negative sign here. So it's positive 5x minus 4x, and that just subtracts to get positive x. So then I'm going to put the negative right here, because the outside values must have a negative value, and I'm going to put the positive inside here. And then it works out because 5 times negative 4 is negative 20. So the answer I have right here is x plus 5, x minus 4. So that would be my answer. Okay, moving on to the next question. 6x squared plus 13x plus 6. So there is no greatest common factor. So I'm just going to start right away with the method I was using before. So I'm going to think of the two numbers that multiply to 6x squared. So let's say I think of 6x times x. Then I'm going to write parentheses and put the 6x out front and then the x there. And let's say for this part I think of 3 and 2. And right now, since we're not going to think of the positive and there is no negative, so we just have to think of it as positive. So I'm going to place a 2 there and the 3 there. And I'm going to multiply the two outside values and I get 12x. The two inside values I get 3x. But these two numbers, 12x and 3x, will not add up to this 13x, and it won't subtract to it either. So I need to try some other values. So I'm going to erase this. And I'm also going to try doing, instead of 3 times 2, I'm going to try 2 times 3. So I'm going to put the 2 there and the 3 there. Try that again. So we get 18x and 2x. But 18 minus 2 is 16, and add them together and you get 20, so that's not going to work either. So we're going to erase this. So since none of these values are working, maybe this first 6x times x was wrong. So I'm going to start that over and maybe try 3x times 2x instead. So I'm going to erase these values and I have to start over from the very beginning, but it doesn't matter. So 3x and 2x. I'm going to try that first. And then I'm going to try doing this 2 times 3 and plugging that in there to see if we have any values. So 3 times 3 is 9x, and 2 times 2x is 4x. Turns out that if we add 9x plus 4x, if we add these two numbers together, we do get 13x. So we just have to put two positive signs in front of there, because this part is positive and this part is positive, so both of them are just going to be positive. Turns out that if you add 9x plus 4x, it does equal 13x. So this combination is right. So the answer is 3x plus 2, 2x plus 3. So sometimes you have to try more than one and you have to keep erasing and seeing if all these values work. But after you do a lot of these types of problems, you'll sort of see what numbers you want to try first. So the next one says 6x squared minus 7x minus 3. So like this previous question, I'm going to try the 3x times 2x because that worked before. So I'm going to try that again. So 3x times 2x. So I'm going to write 3x and then 2x. And here it's negative 3, but we're going to pretend it's just a positive 3. The only factors that work is 3 times 1. So, but now we have to think of whether 3 comes here or 1 comes here first. So I'm just going to write 3 and 1 first. So I'm going to multiply the two outside numbers and I get 3x. Two inside numbers, I get 6x. But 6x plus 3x doesn't equal 7x, and 6x minus 2x doesn't equal 7x either, so these numbers don't work. So we're going to try a different combination. So what if instead of 3 times 1, we tried 1 times 3? So I'm going to try that, 1 times 3. Then the outside numbers, we get 9x, and the inside numbers, we get 2x. And it turns out that if we do 9x or negative 9x plus 2x, we do get negative 7x. So I'm just going to write a negative sign there and do negative 9x plus 2x. And then we transfer the negative sign here and the positive sign here because this 2x goes there and this arrow connects right there. We think about this again, and 1 times negative 3 does equal negative 3. So this combination does work. So the answer is going to be 3x plus 1, 2x minus 3. Okay. Now we're going to move on to this last problem right here. 24x squared y plus 34xy plus 12y. And at first that may seem kind of hard, but we're going to think of the first rule, factor out the greatest common factor. And the greatest common factor here is 2y, so I'm going to factor that out first. So 2y, 12x squared plus 17x plus 6. So that makes it a lot easier. So then we're going to think about this inside part only, and I'm going to think about the factors for 12x. I'm going to try 4x times 3x. So I'm going to write 2y and then write 3x and then 4x. And then I'm going to think of this 6 right here. So this could be, let's say I think of 3 times 2 first. So I'm going to write 3 and 2. Then I'm going to multiply the two outside values, and we get 6x. And the inside values, and I get 12x. And it turns out that 12x plus 6x, 12x minus does never equal 17x. So we know that this is wrong. So we're going to try something else. So maybe instead of 3 times 2, we can try 2 times 3. So I'm going to try that. 2 and 3. So the outside we get 9x, and on the inside we get 8x. And if we add these two values, 9x plus 8x, we get 17x. So I'm going to write plus here and plus here. And that's okay because the plus is here, so positive 2 times positive 3 also equals positive 6, so that works out too. So then the answer we get is 2y, 3x plus 2, 4x plus 3. Okay. Now we're going to move on to quadrinomials, and this is when there's 4 values. And what's important about this is grouping, and so we have to group two numbers that have some kind of factor or common factor. So in this case, we can think of maybe this and this because they both have a y, or maybe we can also think of 2xy and 6x because they both have an x. So it doesn't really matter. I'm just going to go with the black parts first. Or, yeah, they'll give you the same answer, but I'm just going to do the black. So if I think of 2x, so I'm going to group them together and write 2xy plus 3y. So that's the first part, minus 6x minus 9. Second part. So I'm going to group these two together and group these two together and factor out some common factor between both of them. So in this one it would probably be y, just y. So y it'll be 2x plus 3. And this part I'm going to say the common factor is negative 3. So negative 3 and 2x minus 3. Or positive because this is negative. And here we can see that this 2x plus 3 and then 2x plus 3 is exact same. And what we're going to do here is we're going to group these two together again and write 2x plus 3 and take these two values and write y minus 3. So that would be our answer. And you might say, why does it work to take the 2x plus 3 and group them together like that? So we're just going to pretend right here. We're going to pretend that 2x plus 3, we're going to substitute that with the capital letter A. So we're just going to say A is 2x plus 3. So if we substitute that, we get ya minus 3a. And we know that if we want to factor out a right here, it's a y minus 3. So that's basically what we're doing, and then we're just plugging this back in here. That's basically what we're doing, but it's kind of hard to see that because 2x plus 3 is kind of a longer equation than just one variable, but that's basically what we're doing right here. And it would also work by thinking about 2x plus y and negative 6x2. So we can also try that, but I'm not going to do that right here. You can try that on your own. So next one says 9a squared b minus 8a squared minus 9b plus 8. So we're going to choose two values that have some sort of similarity. So I'm going to start with this and this because they both have this b and 9 in them. So I'm going to write that in the order I want it to be in. 9a squared minus 9b minus 8a squared plus 8. So I'm just rearranging this first equation. And then I'm going to factor out the common factors. So in this one it would be 9b, and we get a squared minus 1. And here we have negative 8a squared minus 1. And we get the a squared minus 1, a squared minus 1 here. So we can do the exact same thing, this blue part that we've been doing before. And we get a squared minus 1, and we get here the 9b and then the negative 8. Then we get 9b minus 8. But then we have to check this equation again to see if we can factor this part any more. And it turns out that this part, a squared minus 1, if you remember the rule, I'm going to write here, a squared minus b squared equals a plus b, a minus b, then you'll recognize that this can be factored to a plus 1, a minus 1. So I'm going to still factor this out to a plus 1, a minus 1, and then write 9b minus 8. And that would be the full factored out form. So this would be our answer right here. And factoring can seem kind of hard at first, but then, so what I would recommend is that you practice a lot of practice problems so you get better at them. And especially for trinomials, if you practice a lot of problems, you'll start recognizing what numbers to start using instead of guessing and erasing, guessing and erasing. So try a lot of practice problems and then you'll get a lot better at factoring. Thank you for watching.